In college algebra, we graphed polynomial functions. We started with multiplicity on Friday last week, did all that, and now we're on number 4. So we're going to review multiplicity and then eventually graph. For number 4, you set each factor equal to 0 so that you can find the actual zeros, which is very doable in your head. Because we know x is 5, negative 2, and positive 1/4. Now, multiplicity, what happens when, to describe the 0, is does it bounce or pass through? Pass through the x-axis. That's what it's asking. 5, negative 2, and 1/4, that's easy. So because this has an imaginary 1 for an exponent, the 5, it's odd. Therefore, it passes through. Look at negative 2's exponent. It's a 3. That's odd. Therefore, it passes through. And then 1/4 has a 4 for an exponent. It's even. Therefore, it bounces. And that's it. That's all number 4 is asking. On number 5, we have 4 terms. So factor by grouping. So you group the first 2. Group the last 2. Be really careful with your signs here. I personally would write it like I just did. It's easy to mess up that minus sign. And you take a GCF out of each parenthesis. So we take an x squared out. You take a negative 1 out. And look at the parentheses. They're identical. If that happens, you've factored successfully. You write the 2 GCFs in their own parenthesis and the repeated parenthesis, x plus 3, one time. Now, you can sometimes take it further, and you can. X squared minus 1 is the difference of 2 squares. So we can factor that into x plus 1, x minus 1. So we know we have zeros at 1, negative 1, and negative 3. And look at the exponents. They are all 1s. They're all, in other words, they're odd. So all 3 of them pass through because of the odd exponents. All right, moving on. Next one, I believe we're actually going to graph. So it's a 4-step process. We did the lead coefficient test in a previous video. We just talked about x-intercepts and multiplicities. A y-intercept, you find that by plugging in 0. That's pretty easy. It's usually very quick, and you can usually do it in your head. Maximum number of turning points, that's n minus 1. And n is the largest exponent. So, for example, on this problem, largest exponent is 4, so n is 4. Which means there are 3 possible turning points in the graph. That's going to help us. It's going to help guide us when we're drawing the graph. That's all it is a guide. All right. Lead coefficient. We already said 4 is n. But remember, more importantly, it is even. Then you take the sign in front of it, and it's positive. So then you go to your in behavior chart, and that means it is going up on the left and up on the right. For x-intercepts, we got to factor it. And I see an x to the fourth, which is a little weird. So let's kind of play around with numbers and see if we can figure it out. I know x squared times x squared gives me x to the fourth. I need to multiply up to 1, and there's only one way to do that, 1 and 1, but they need to add to -2. So if we make them -1, it multiplies to +1, adds to -2, and it works out. But we can factor it further. We have two sets of difference of two squares. We have x plus 1, x minus 1, x plus 1, x minus 1, which means we have x plus 1 squared and x minus 1 squared. That means we have an x-intercept at -1 and at +1, and they both bounce because of the exponent 2. For the y-intercept, let's plug in 0. And 0 to the fourth is 0. 0 times -2 is 0. And we have a +1. That is our y-intercept. All right, you have more room than me. You should be able to graph this. Make a XY grid. And because of the x-intercepts and y-intercept, make 1 dash right, 1 dash left, and 1 dash up. And let's make dots on those 3 spots. All right, now look at your in behavior. It's up over here and up over here. When I hit the x-intercept, it's supposed to bounce. We wrote that, right? So we're going to draw the line down. It bounces. I need to go back down to that x-intercept, and it bounces, and we got it. Look at how many turning points we said there would be. 3, and I see 3 turning points. The last thing, you can check your calculator and make sure it looks right. My graph looks a little shaky. I think that's because I was drawing slowly. So hopefully that made sense. Let's try one more. Number 7 is already factored for us. This is very nice. The x-intercepts will be easy. But I need the largest exponent. So I'm going to simplify. I am A-okay with you doing the simplifying in your head to find the largest exponent. It's very straightforward. You don't have to simplify on paper if you don't want to, but I'm going to. So x minus 1 squared is x squared minus 2x plus 1. And then x plus 2. I need to distribute the -2. Now I need to distribute to each of the 3 terms to the 2 terms on the right. So we get -2x cubed minus 4x squared plus 4x squared plus 8x minus 2x, I'm running out of room, minus 4. So we have that. Whoops, that's not a 2. That's a 3. All right, so largest exponent is 3, and it's odd. The sign in front of the 2 is negative. That means on the left, it starts going up, and on the right, at the end, it ends going down. My x-intercepts are pretty easy because we have x minus 1 equal to 0 and x plus 2 equal to 0. For the x minus 1, that's raised to the second power, so this one bounces. And for the x plus 2, it's raised to the first power, so it passes through. Almost done. Y-intercept, plug in 0. You can plug into the typed formula or the simplified one. And we get negative 4. Turning points, that is 3 minus 1, so we have 2 possible turning points. And we're ready to graph. So make a giant XY plane. And make 1 dash right, 2 dashes left, and 4 down. We start up, but we end down. And at negative 2, it passes through. So I come down and I pass through. Now this part's tricky. There's no way, well, there is a way, but based on what I've shown you, there's no way to know exactly where it goes, but I do know I end up turning and I hit that spot right there. Now I need to hit this x-intercept right here. So I'm going to keep going. And it bounces. And we have our graph. And that's it. Hope that made sense. See y'all later.